mentioned the electric fields earlier. Basically, this is just the region around the charged object where if you were to put another object in there, there would be a force exerted on it. We represent this with a circle for the object and then the force lines coming out of the object in this case. And if you look at how many force lines are coming out, that tells you how much charge is on the object. So as you see here, charged letter C has a lot more lines of force coming out of it, so the charge is much larger on C than it is B, and then B is even bigger than A. Now I want you to notice the field lines in these two pictures here on the right. The positive charges have the field lines going out from the charged objects. Now this is going to be important for why these things interact the way they do, with the positive and negative repelling each other, and why positive and negative together actually attract. So positive goes away from the charge, and negative actually comes towards the charge. Now this picture down here on the left side is showing you that this is a three-dimensional field. We've been looking at these pictures so far, and they've been the flat two-dimensional drawings. These fields are actually in every direction out from the charged object. So here are some force field diagrams. We have the positive charge where the field force is going out from that charged object, and then we have the negative charge up here where the force fields are going into that negative object, negatively charged object. So you can see how these things are interacting with each other. When they are opposites, they're actually attracted to each other. Now on the right side here, we have two positive charges. With both of them coming in the outward direction, they bump into each other, and that keeps them from going together like we have here on the other side with the opposites. The force fields are actually bumping into each other, and those charges are being repelled by each other. Now, static electricity is something you probably are all familiar with. You have this anytime you are walking across the carpet and you grab a doorknob and you get a slight shock. Or you do it on purpose and rub your feet on the floor and then walk over to your sibling and touch them and they get a little jolt. This happens to everybody. It also can make your hair stand up when your hair gets positively charged because you've pulled off the electrons with, say, the balloon we rubbed on our head yesterday, or even a comb can do this. Now, it's called static electricity because static means it's not moving. Those electrons are building up, but they're not moving. Now, they will move when you have a static discharge. We'll talk about that in just a second. Now, you probably all know by now I love The Lion King, so of course I had to put this little comic in there. And in the true fashion of cats, both big and small here, we have another little cute kitty that has been tortured. We've got some static electricity going on. So it says, yeah, real funny, rub me on the carpet and then put me in the shipping box. You will pay for this. So rubbing the cat on the carpet has created a situation where you have a negatively charged cat and you put him in with the packing peanuts, which are going to be sticking to him because there will be some positive charges on the part of those packing peanuts that are attracted to the cat. Now, static discharge, you guys are all familiar with this as well. That's that little spark you see when you get shocked, when you touch the doorknob. In a larger scale, you would see this with lightning. This is where we have the negatively charged cloud, the positively charged ground, and the lightning will jump from the negatively charged cloud down to the positively charged ground to even out the charges.